All right, so we're going to continue with structures today, probably finish up with structures today. There are just a few more things to review and to work with, including using structures in arrays as well as using structures within functions, which we've already done a little bit of already. Remember that we are on Piazza and we are on YouTube, so if you have any questions, please go ahead and post there. Otherwise, to review here, remember that we went through this tutorial style. We developed a structure that modeled a film, right? Including the film's title, which is a string. The EIDR, that's a unique identifier that all media has. We just wanted to model the director for now. Of course, you can get fancier and model everything, all the actors and all of the staff or whatever. We're just going to keep it simple for illustration purposes. We also added in an IMDb rating, which is a number on the scale 0 to 10, right? But we also identified that a person itself is a structure that has multiple pieces of data. Anytime you find yourself saying, this thing is represented by more than one piece of data, that should be screaming out to you, put that into a structure. And so we did that. We defined a person, which represents a director in this case. And we use that in our film structure down here. Then the person itself also had a date of birth. So what is a date of birth? It's a year, a day, a month, and a date. So we put that into a structure as well. And we declared it like this because if you were going to use date, you have to declare it before you use it. So date, then person, then film, because each one of these has a dependency on the last one. So order matters. We then went on to create a factory function that allowed us to create a brand new film and return a pointer to it by taking the EIDR, the title, the director, and the IMDb rating. All we did was create the structure using malloc. We filled it in with all those values, and then we returned a pointer to that dynamically created structure. We also created a function here to print the film because we actually wanted to see the results. Now, when we left off, there was a syntax error that was preventing the full execution of this program. It was just me. It turned out it was just me forgetting the semicolon down here. But I did want to draw your attention here to this shorthand for creating instances of structures. For example, if you want to create a date, you can go ahead and use the curly bracket notation, just a quick date here, a quick date where you provide the year, the month, and the day. The order here matters. Right? If you put the year last, well, that's not how you declared it over here. The year is first. So the order there matters. But otherwise, you can go ahead and use this quick and dirty syntax if you just need an example to play with. Well, we also did this with a person, right? Dennis Villanueva, director. And he was, I did update this data. He was born, I was really close actually, in 1970. If we made it the Unix epoch. He was born 3 years before that. And it looks like he just had his birthday, right? So, earlier this month, or early last month. Okay. I created 3 films that he actually directed: Arrival, Dune, and not Endgame, but Blade Runner. I didn't fix that. There we go. Right. And then we printed them out. So let's just go ahead and see this in action. Make sure that it actually works. I'll just GCC everything. Oops. I'm in main. GCC. Everything together. Oh, and then where's Endgame? Okay. We talked briefly about freeing things up. We're not going to get into that. I'll leave that as an exercise. There we go. A dot out. And here I'm only printing these 2, but of course you can print the third one here if you really want to. Dune, then Arrival first, I guess. We'll go in well, let's go in alphabetical order here. Doesn't really matter, but you can see that this will execute, and it's only printing the things that we designed it to print, right? The title, the director's last name, comma, first name, and then the IMDb rating here. Right? It's not printing out all the data associated with it, just the data that we were interested in. If you want a different formatting, of course, you can go ahead and create another function to do that. Okay? So, to recap on the usage. You can declare a structure once you've defined it using this regular syntax that you're familiar with. If I want to create an integer, int x. Well, if I want to create a film, once I've created the definition of a film, I can go film f. right? Same rules apply as to the naming conventions, lower camel casing conventions, right? You can easily create a factory function to simplify the creation of instances of structures. And we'll get more practice here today with an alternative that I'll show you. You can also use pointers to structures that also have pointers to various other structures. When you have a pointer to a structure, though, instead of using that dot operator, right, the direct component selection operator, it's a period, so we call it the dot operator, you use a arrow operator. Right? Now, to take a look at what I mean by that, let's go ahead and go into film.c here and take a look. Since I was given a film star, a pointer to a film, if I want to access its title, here's a better illustration here. If I've given a film star, if I want access to its title, I have to use the arrow operator. You can dereference, surround it with a bunch of parentheses, and then use the dot operator, but why not just go with this nice syntactic sugar, right? All right. If you have a regular old structure, though, then you use the dot operator. Once you've defined a structure, you can dynamically create structures using the Sizeof operator. Here, last year I was creating books, so I'll go ahead and change this to a film. Once you've defined a film, you just use Sizeof and film, and that's how many bytes a film takes. The compiler will be able to deduce how many bytes it is based on your declaration of that function, of that structure. It's able to go and see that, oh, well, a film is 2 character pointers, that's 8 bytes each. There's a person, well, that consists of 2 more character pointers, so 32 plus the date. Oh, that's 3 integers, so that's another 12, etc. It's able to add all that up. Compilers are dumb, but at least they can add stuff up. All right. So, other common convenience functions might include a function to create a human-readable string representation like we did. Right? A function to free up aspects, or this is called a destructor function. Sometimes these factory functions are called constructors, right? Because they construct a new film. Well, what's the opposite of construction? Destruction. If you want to free up all the memory associated with it, you can create a destructor function. Free film or something like that. Right? You can also have what's called an initialization function. And that's what we're going to do here today when we look at some shortfalls when it comes to arrays. Similar to passing in arrays of integers, you can pass in an array to a function of an array of films instead, for example. Now, let's go ahead and pick it up from there and do just that. I've got these 3 films here. What I want to do is I want to store them into a film library of some sort. That means that I'm going to have an array of not integers, not an array of doubles, not an array of characters, but an array of films. If I were to do an array of integers, what would that look like? Int ARR, right, equals int star. By the way, I decreased the size. Can you still see it in the back? Okay, good. Malloc, size of int times, and I want 3 of them. Right? I want 3 films here, but if I wanted 3 integers, I would multiply it by 3. But I don't want integers, do I? I want films. So how would this look differently? Film instead of int. Film instead of int. Film instead of int. Right? Now that creates an array that is able to hold 3 film structures. How do I assign it? I'll keep it as ARR. ARR sub 0, I want that to be arrival. By the way, these are all very good films, but I have not seen Dune yet. I don't care about spoilers because the book is 50 years old, so who cares? Right. Array of 1 is equal to Blade Runner. There we go. All right. This is not going to compile, and it's not going to compile for a very good reason. Let's go ahead and try to compile it. And it's going to complain about these 3 assignments. There's an incompatible type here. One of them is of type film, but one of them is of type Filmstar. So let's focus on this one line here, this line 23. The thing on the right-hand side, arrival, that is a film pointer, Filmstar. The thing on the left-hand side, what is that? Well, ARR is a Filmstar, but ARR sub 0, just one of them, is a regular old structure. So how do I reconcile these two things? How do I reconcile the fact that I've got a pointer over here on the right-hand side that needs to become a regular old structure so that I can assign a value? Dereference it. Dereference it. Dereference it. Now, the compiler is perfectly happy with this. But this is not what you want to do, right? And I'm going to show that. I tried to put this together before lecture, and it looks like a mess. But we'll go ahead and take a look at it anyway. So here is basically, here's going to be a visualization of all this memory. I'm just going to jump to the last here and then go one before it. There we go. All right, so I've got Arrival Dune. I forgot to rename Endgame, so forgive me for that. But I've got all this memory sitting around here, right? And all these references, all these pointers. Here's the original film, and this is probably Arrival, and it's pointing to this string down here, et cetera, et cetera. And it's pointing to the Denis Villeneuve over here, and his date of birth, et cetera. The thing I want you to take away from this is how many boxes representing films are there here? I count 1, 2, 3. Those are the 3 originals. Those are the 3 originals from lines 18 through 20. Now I count another 1, 2, 3. Those are the ones from this array right here. What have I done by simply dereferencing this? I've copied everything in that film over to everything over here. I've got now 2 copies of Arrival. I've got 2 copies of Dune. I've got 2 copies of Blade Runner. Right? So lots of memory, lots of potential for memory leaks here. Okay. So let's rethink this. How can I just have 1 copy and 1 copy over only? I'm going to go ahead and reverse that. All right, now I've got those 3 other copies there, and I've got these 3 new copies. Instead of doing it like this, let's think of a different way of doing it. The first one, ARR sub 0, that's a film that has already been whose memory has already been set up, right? It looks something like, again, it looks something like this in the visualizer up here, this thing right here. It just doesn't have anything set yet. So let's go ahead and think of a way that we can have an alternative of creating films. I can't have 2 functions called CreateFilms, by the way. So what I'm going to do is I'm going to call this InitFilm. The key difference here is that with CreateFilm, I gave it all of the data, and it created a brand new film and then returned a pointer to it. What I'm going to do with InitFilm is I'm going to assume that I already have a film created in memory. And I'm going to give you the film, and I'm going to give you all the data. You're going to put it all together. You're going to assemble it. Right? So instead of a factory function, it's like I give you the raw materials, and now you're an assembly line. And you assemble all that data together. You're no longer returning a film. You've taken a film as input here, and then you're going to fill it with all these pieces of data. Now, what might that look like? Let's go ahead and implement that. Okay. So I want to set the, say, EIDR first. F.EIDR is equal to, for those of you that have not been coming to lecture on a regular basis, remind me, or for those of you that have, remind me, what does this do? strdup, how should I pronounce it first of all? Dupe, because it stands for duplication. It is a deep copy string function, right? I suggested that you write your own, but it's already built in. Why not use it? Right? So strdupe here. I'm just going to cut and paste this up here. There we go. That does my work for me. In fact, you know what? A lot of this stuff is the same. In fact, all of this stuff is the same except for the creation of the film and returning the film. All I'm doing is taking a film and filling it with all of these values here. Now, by the way, do I use dot or do I use arrow here? Arrow, why? Because it's a film star, a film pointer. And so you need to use the arrow operator. What red flag should be screaming out to you right now? I copy pasted, right? That is a sin. So how do I atone for my sin of copy pasta? Don't do it, right? One of these functions can call the other one, and I don't have to have any duplicated code. Not only did I commit copy pasta, but I also violated the DRY principle. DRY, don't repeat yourself. Right? So, what if I called InitFilm from CreateFilm, right? Passing in that film, EIDR, title, director, and IMDb rating. There we go. Much simpler code. That harkens back to what we did last time, where we started out with this print function, and then we realized, well, we might want to print to a socket, or we might want to print to a file, or we might want to print to something in the future. So why don't we create a more general film to string function that then print film can actually use, right? So I don't have duplication of code. DRY, don't repeat yourself. Don't copy pasta. Great. Now, how does that look over here in the demo? I need to initialize, not create, arrival. So I'm going to go ahead and call InitFilm, and I'm going to pass in that first film. Maybe that's how I pass it. Maybe that's how I don't pass it. I don't know. I'm going to copy the data that we were using before, and I'm going to do the same for the other two films here. Copy, print it. And I'm actually going to get rid of this for now. Right. Dune should be the third one. There's that data. Blade Runner will be the third one, sorry. And then, of course, change 1 and 2. There we go. So GCC, and I'll just go ahead and compile everything together in one shot here. It's still going to complain. Why is it going to complain? Let's just take this one. Incompatible type for argument 1. Now I have the reverse problem that I had before. Remember that I couldn't just assign the arrival, which was a Filmstar, a pointer, to a regular old film? Now I can't pass a regular old film to something that expects a Filmstar. So I have the same problem, but in reverse. How do I take this regular old film and turn it into a Filmstar, a pointer? Ampersand right in front. Ampersand right in front. Ampersand right in front. It should be happy about this, but I think it was complaining about something else as well. Ooh, I misspelled director? Oh. Yeah, where? Film.c. 17, thank you. Director. There we go. Did I misspell anything else? Yeah. I misspelled Blade, Dune, and everything else. So, oh, okay, that's fine. Because I no longer have those names anymore, I'm going to go ahead and get rid of these. Actually, how would I do this? I would end up printing that one, and that one. That seems tedious, though. Paste, paste, paste to print them all. Now that they're in an array, maybe there's a better way to do that. But otherwise, it will still run. It should still work. There we go. It works. Right. So, which is better? Half a dozen of one, 6 of another. Right? Do you want to create films from scratch? Do you want to create the films outside the function and then hand them off so that it can assemble them? Right? One's a factory function, and one's kind of like an assembly function. Why not both? Right? Go ahead. It makes it more flexible, right? And I think that that's what your hack does. You do both of them. Okay. Well, then that leads a question here of, well, I've got 3 films now, and I've got them all in an array. I want to print them all, period. I don't want to have to call print function twice, 2, 3, 4, 5, 6, 7, 8, 9 times, right? If I were to do this, of course, it would look something like this. Instead of print film, print film, print film, it would be for int I equals 0. I is less than 3 in this case, I plus plus, and it would be print film array sub I. Even that seems tedious. What if I have an array of films and I just hand that off to a function that prints them all? So instead of print film, maybe I would have a function called print films. Right? It would still take an array of films, a film pointer, but now that there are 3 films, it's a pointer, and I also need to know how many of them are in there. So n. Implicitly, that's the size of the array. Okay? And I could put that over here in film.c. And I'm just simply going to take the code that I did over here, so I don't have to rewrite that for loop, and put it inside this function. There is a problem, though. I need to fix a couple things. First of all, it's not always going to be 3. It's going to be n. Right? And we're given this film. Actually, that's it, right? I'm just going to call the print function, and it'll take care of it for me. No? Oh, thank you. Not ARR, but F. In fact, at this point, I would say that my abbreviations are kind of losing. So let's call it films, right? And it still works. But now let's go ahead and, or it still compiles at least. And now let's go ahead and call that function, print films. There we go. We'll pass in ARR. I should have called it films, but so be it. And 3. And so much better. Now I've got a function that takes care of that for me, regardless if I have 3 films, 4 films, 80 films in my library. Right? All right, so what does that look like now? Instead of 1, 2, 3, and then 1, 2, 3, you would only have these down here instead. This is basically a visualization. Now, this is not films. This is students. This is from the book. This is not from Zybooks. This is from my book, the suggested reading. But the way that I've done it here has contiguously allocated memory. Think of these as not students. Think of these as films. So here's the first film. Here's the second film. Here's the third film, all in memory. If you want to, I encourage you to pick up that book and look at alternatives. For example, you could have an array of pointers instead. We have enough time if we really want to do it. What would this look like? So instead of a contiguous allocation, what you have is an array of pointers, and then this pointer points to that film over there, the second pointer points to that film over there, the third pointer points to that third film over there. Right? It's pointing all over the place in memory. It's kind of like a 2D array. In fact, that's exactly how you would declare it. Student star star, int star star, or film star star. Right? That would mean that you have an array of pointers, and each one of those pointers is pointing to a row of films. But in this case, the row of films is only one of them. Right? Each row is of size 1, and that's how I visualized it here. It could be located completely in different parts of memory. Right? If we want to, we can go ahead and take a look at this and see how this is done. Yes? No? You want to see it? All right. We've got enough time. Although you may find me out that I'm not able to do it off the top of my head. I'll probably be able to do it. Don't worry about it. All right. So I'll restore these things over here. And here's the alternative. Film star star films. Right? This is an array of pointers. It's an array of pointers. Okay? And so we would call malloc films star star malloc. Now, I'm not asking for size of films anymore. I'm asking for what? It's an array of pointers to films. So that's going to be film star. You can put a space in here if you want to. I think it looks nicer. How many of them do you want? Well, I've only got 3 films, so times 3. It's probably better to put that into a variable at this point, n, so that I can reuse it, but I'll let you do that right, when I post this. That initializes this array of pointers over here. So all that has done is created this thing right here. It hasn't actually created this thing, this thing, this thing, or set them equal to these pointers. That's okay, because I've done that up here with these 3 movies. In fact, I'm going to go ahead and move this down here. Right? There. And now all I need to do is set them equal to those pointers. So films sub 0 is equal to arrival. films sub 1 is equal to Dune, and then Blade Runner. Now, if you'll recall, this was my first attempt when we had a regular old array of regular old films. It didn't work because I needed to dereference them. But then that led to this kind of duplication of stuff. I don't have that same problem here because I'm not going to dereference them. Films of 0, that's already a film star. It's already a pointer. The thing on the right-hand side is already a pointer. So these are the same things. And the compiler is not going to complain about this one bit. Because a pointer, yeah, sure. A pointer points to a pointer, right? Pointer points to a memory location. But that does mean that I can't use this anymore if I want to print it out. Print films. Print films on, what did I call it? Films and 3. The compiler will complain about this, and rightfully so, because print films requires a film star, a pointer, to an array of films where there are n of them. Let's say n is 5. Right? That's not what I have here. What I have here is an array of pointers. That's okay. Let's go ahead and make it. Print films, what should I call it? Film star star, first of all, and there are n of them. Can I have two things named print films, first of all? No. Print films array? Okay, that's good enough, right? I would put something in there by reference or something like that. Technically, the other one's already by reference, but this is by reference by reference. So, by pointer, right? Or version 2. Remember, in computer science, there are only two difficult things: cache invalidation and naming things. I'll just go ahead and go with V2. Version 2, right? So how does that look different from print films version 1? By the way, you would generally go with one or the other, right? Not support both, right? So you're given an array of pointers to films. You still iterate over them because there are n of them. But when you pass it to print films, film sub I is already a pointer. You don't need to get its memory address. Right? And this, well, come on, up. Oh no, are you frozen? All right, that terminal is frozen. Hopefully that doesn't freeze everything else. I'll go with V2 here. There we go. Hopefully that saves. Oh, come on, really? Okay, there we go. There. Films, did I name it wrong? Yep. Films. There we go. All right. Films V2. Okay, this probably didn't save then. Films V2, save it. And I call it films, right? Yep. Anybody see the problem?
I believe the header is still out.
Say what?
I think the header is still out instead of films.
That should be okay. It really doesn't matter what you call it over here, but I'll go ahead and update it over here. Films V2, films V2, films. Film star star, film star star. All right, I'm probably going to have to get rid of the const here. Fine. I'll explain this here in a second. And oh, the const was already gone here. Maybe that was the problem. I could restore that, but I'll leave it out. So here's the secret and why that was a problem. Const only works one level deep, right? It says that you're not going to be making changes to this pointer array. It doesn't say anything about, are you going to be making changes to that thing over there? Right? So what you would have to do is say, I have a const star, so I'm not going to be making any changes to this thing. Then in parentheses, a const star, because I'm not going to be making any changes to this thing either, film. And Off the top of my head. You're asking a lot. Okay.
Like a very basic,
Const.
yeah, what you like.
Filmstar. Your const star, something like this.
Okay, that's just something.
Yeah, yeah. Take a look at the book. I do put it in the book, but in the searching and sorting section.
I just didn't know what you meant by like you did.
You'd have to go a couple levels deep there to make the promise. I'm not going to be making any changes here, and also I'm not going to be making any changes here. And if you had pointers to pointers to pointers, you'd have to chain that all together to say const. But you'd have to get all your parentheses right. You'd have to get all your stars right, etc. Right? And I don't want to do that right now. There. And this should run perfectly fine. Right? And you have two options now. Right? You can create films that are already created and just initialize them. You can create them with this creation factory function and deal with star. If you had to make a choice between one or the other, I would say keep it simple and just go with something that looks like this. Right? Especially if you're not too confident in using pointers to pointers. I'd say keep it simple and do something like this. Now, if you want to be complicated, go ahead and do something like this. But if you want to be even more complicated, then I'm going to tell you to read the book and get something that looks like this instead. Oh, sorry, I have to bring it over. There. This is the best of both worlds. Not only do you have an array of pointers, but you have a contiguous array of structures. And then you have these pointers pointing to each one. So why the additional layer of abstraction here? Why the additional layer of complexity? What if you start moving things around? What if this film is out of order? What if you need to sort it? And you need to switch this film and this film because this one was published earlier, right? You want to sort them according to the publication date or the release date. And so you have to take this piece of data here and this piece of data here, and you have to swap them. Well, if that's 40 bytes, then maybe you don't want to swap 40 bytes, 40 bytes, 40 bytes all the time. It's a little bit inefficient. 40 bytes, who cares in the grand scheme of things? But if these are larger structures that are thousands, millions of bytes, making a copy from this chunk of memory over to here temporarily, this chunk of memory over here, and this chunk of memory back over here to swap them, that can get quite expensive. But if you do it all with pointers, you don't have to change these two films at all. All you have to do is make them point to different things. Right? And so that's the advantage of this one. Again, if you want to challenge yourself, go ahead and read the book on how to do this. Otherwise, don't worry about it. Right? Again, my advice is to keep it simple and go with a solution that looks like this. Okay? Okay, wow. We're blazing through. I will make sure that all of these are in the notes. They'll probably be separate files since they're all large files. So I won't embed them in the notes. I'll just upload the files individually. So C code. So summary. So here's where one of the principles of design comes in, right? When you define a structure, or when you have to define a structure, like say for a baseball team in Lab 10, when you did File I/O, we gave you baseball teams, and you had the team name, you had the wins, and you had the losses, right? Think about what the essential pieces are to that thing. What makes up a team, right? Well, what data do you need right now to get the job done? To print out the win percentage and then sort by win percentage so you can report who is the top team, who was the worst team that year. Right? You need those three things. You don't need the city, you don't need the state, you don't need the zip code, you don't need the manager, you don't need the players. But if you want to do more with data, then you do. And that's when you need to start thinking about decomposition. Think about a player. What is a player? Well, a player is a first name and a last name. Maybe a social security number. Maybe a player is a person, right? So maybe we want to generalize that to be a person because a manager is also a person. there's not that much of a difference between a manager and a player, so we'll go ahead and abstract that to a person. Now what is a person? First name, last name, social security number, et cetera, et cetera. Well, when they're a player, they have a number. When they're a manager, they have something else. They still have numbers. I'm trying to think of what distinguishes them, though. They have a salary, right? Et cetera, et cetera. So you have to think of each one of these fields or member variables and its type. How do I represent their salary? Maybe a double, maybe an integer. How did we represent dates? Well, we decided ultimately on 3 numbers, integers. The year, the day, the month, and the day. We could have done it differently. We could have done it with the ISO 8601 standard, the string. We could have done it using the Unix epoch, just a single number, the number of milliseconds since January 1st, 1970. There are lots of ways. There's no wrong answer. There are some clearly wrong answers. There are some clearly right answers, but everything in between is up for debate, and that's a design thing. If you're working with somebody, you can go back and forth. Well, I think should be this because it has this advantage and it doesn't have this disadvantage. And then your partner or whoever you're working with, well, I think we should do it this way because this is a different advantage, this is a different disadvantage, right? And then you have to come to a consensus on which advantages outweigh the other disadvantages. There's no right solution in that space of okay solutions, right? There's clearly wrong solutions, like, for example, representing a name as an integer, right? I am not 42. I am Chris, right? You need to represent it correctly. But otherwise, you decompose a structure down until it's one structure, and you just go ahead and implement it. Or you realize that I need yet another structure, because a film has a director, and a director is a person. That's a different that's a different structure. Let's make it. That person has a date of birth. That's a different structure. Let's make it. Right? And so we decomposed a film down into its constituent parts and defined structures for each one of those. Each structure has a use beyond just the immediate use, a date. That could then be extended to be used for a release date. It could be extended to be for a DVD release date, a streaming release date. It could be extended to the actors and their date of births, right? Or whatever, right? The date that they started acting on that movie, whatever. Right? Each one of these has a potential to live outside its immediate use, and when you have that, you have a very good design. So it's open for extension, is what we say. That you can reuse these things in different places in different contexts. Beware of Yagni, though. I think I defined Yagni last time, didn't I? You ain't gonna need it, right? So, when we designed the film, I forget what we wanted to put out, like genre. That was one thing that I rejected at first because, well, if we put in genre, what is that? Well, that's a string, but then you also have subgenres, right? Horror realistic, horror comedy, right? Or intersections of genres. Sci-fi western or something like that. And there are things like that. There was one like a few years ago. What was it called? It was awful, but it was with Indiana Jones. You know what I'm talking about? Okay, maybe not. There were a bunch of cowboys and the aliens invaded and the cowboys had to defeat the aliens. But you could have intersections of genres. I rejected that because it went beyond the scope of what we needed at the immediate time. That would have been premature optimization. That would have been premature over-designing it. Yagni, you ain't going to need that. Right? Don't do it until you absolutely need to. Right? Don't unnecessarily over-engineer your structures. Don't reinvent the wheel. Right? We made our own date because I wanted to show you how to do it. There is a date structure already built into the C time library. I think it's date_t. It's terrible. I hate using it anyway, so I wouldn't recommend using it. I certainly wouldn't recommend using it for these exercises that you're about to do, right? Especially on file I/O last week, or was it? Or no, you're doing structures this week. So when it comes to designing, I think what you're going to do is you're going to connect to an RSS feed and pull like news stories from Husker News, or you're going to pull news stories from UNL News or Reddit or something like that. And when you do that, one of the attributes on those is the date. just use a string. Don't get fancy. Don't use the built-in date function, date time function, because it is terrible to use. Just use a string, right? And get it done, because you ain't gonna need it. Yagni. Right? But in general, you shouldn't reinvent the wheel. If there was already a person object or a person structure that I could easily use and be defined, then yeah, use it, right? Pull it off the shelf and reuse it. Ultimately, the semantics of real-world entities will dictate your design. Once you just start thinking about a person, you start thinking, well, they have a name, but how do I represent their name? Like Christopher Burke or Burke, comma, Christopher, right? Or should it be shortened? Or what about middle names? What about titles? What about suffixes? At that point, it's Yagni. But I would say that, you know, a name should be split into at least a first name and a last name. Because if you ever wanted to sort by last name, you need to isolate that piece of data, right? In order to say A, B, C, D, according to last names, right? All right. So any questions on that so far? No? All right, well, we've got plenty of time here. So I'm going to go ahead and I don't want to get rid of this. So I want to give you a challenge. Touch challenge.c. All right. So I'm going to cut and paste everything I've got over here, except for the film stuff. I don't want to touch these files because I want to post them so that you have access to them. There we go. To do. Print a countdown, right? 10, 9, 8, ... down to 1, and then blast off. But you may not use a while loop, or a for loop, or a do while loop. You may not. Actually, I'll leave that as the challenge. Help me. The smart aleck answer is what? Printf 10 and the line. Copy, paste, paste. Right, 9, 8, 7, 16. Right. All right, so that's the smart aleck answer. All right. You may not hard code your print function, print statements. So, nope, that's not allowed either. You now live in a world without loops. Can you do it? So I'll tell you this. There are languages that do not have loops. They're purely functional programming languages. So let's take stock. What do we have? Well, we've got variables. We've got functions. We've got if and conditionals, right? If-else statements. Yeah. You could create, we could create a structure, okay, so that you could hard code the values, but then you still have to iterate over them, right? So let's take stock of what we do have. Variables, we could do arrays, we could do a whole bunch of things. Let's focus on functions. What if I have a function to print something? I'll do void, right? Countdown is what I'll call it. And I'll take an integer I. Right? In fact, I'll go ahead and define it right here. Now let's think about that countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. When I get to 0, do I want to print out 0? I want to print out what? Blast off. So if I is 0, then I'll print F, blast off, and end line. Else, now it is a number. It's 10, it's 9, it's 8, 7, 6, 5, 4, 3, 2, 1. If it's one of those numbers, then I'll go ahead and print the number and the line, I, okay? But how do I get to the next one? How do I go from 10 down to 9? What if, call countdown. What if this were 10 instead? And now this is not code. But what if the value stored in I was 10? It would end up printing, in this else statement, it would end up printing 10. And do I have a function to print 9? Yeah, Countdown. On 9, but in this case, since I'm doing it with I minus 1. Right? Wait a second, a function calling itself. Right? Yeah. How does that work? Let's go ahead and see if it works. Countdown. Again, I'm going to start at 10. No, GCC challenge. Let's see what happens. Oh, it worked. That's called recursion. I wonder what recursion is. This is going to I don't think DuckDuckGo supports this, so let's go ahead and go with actual Google here. Google, what is recursion? Oh, come on. Where's your joke? Recursion. There we go. There's the joke. If you just search for recursion, it asks you, did you mean recursion? Yes, I did. Did you mean recursion? Yes, I did. So what is recursion? Recursion is self-reference. One form of recursion is, in plain old language, me, myself, and I. You are referring to yourself, right? Well, you can have, in object-oriented programming, you can have objects refer to themselves. In non-object-oriented programming, you can have a function that refers to itself, right? That's called recursion. If you have a function that calls itself, then that's a recursive function. Yeah?
How can it call itself before getting down? Like how can it do that? Because if the scope of the function, like...
Well, in this case, I defined it before I used it. But you're right. I defined it and I used it at the same time.
Yeah,
Right? So how does that work? Let's ask MC Escher. There we go. How does it work, MC Escher? One hand is drawing itself, right? So the actual engineering answer is that the compiler is able to figure it out, and the compiler is able to say, oh, you want to call your function itself. Well, this function has a memory address. So all you're going to do is jump to that memory address. Comes down. Oh, you want to call that function again? Jump to that memory address. What is this thing? A loop without writing a loop. Right?
Theoretically, it's almost like a while loop.
It is like a while loop. The only difference is that you are abusing the call stack in order to get this. So let me go over here to Python Tutor and edit this code, get rid of all this, and visualize this execution. All right, so let's step through this. We call countdown on 1, or on 10, right? What's going to happen when countdown calls itself again? Stack frame, stack frame, stack frame. Right? There's another stack frame that receives the value 9. There's another stack frame that receives the value 8, 7, 6, 5, 4, 3, 2. Come on, keep going. 1. Keep going. There. Now when it receives 0, what's it going to print? Blast off. There we go. You see it printed up here. And now the reverse is going to happen. Function called function called function called function. And then what's going to happen to all these stack frames? Pop, 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 pop. Come on. There we go. Pop, pop, pop. And we're back down to main. So instead of defining my own index variable, I running from 10 down to 1, then blast off, I am abusing the call stack to do my work for me. That can be a good thing, but 99% of the time it's a bad thing. For example, what if you wanted to count down from 1 million? Well, let's go with 10 million. All right. Well, first of all, this is going to be probably pretty slow because it's actually got to print all this stuff out. Let's find out. You should have died a lot sooner than that. But anyway, what's happening here? There we go. It was only able to do what? 3 million? 10 million, so that's 300,000 or so. 300,000 and some change. Why? It's not returning. It's stack frame after stack frame after stack frame after stack frame after stack frame. What happens when you eventually fill up the stack? Stack overflow. And so I now know that I can call something like 320 some thousand function calls, and then it will stack overflow, right? So you're abusing the call. Of course, this would have worked perfectly if I just had a regular old for loop, right? One stack, that's never going to overflow. It's not that interesting to watch it count down from 10 million, but it would still at least do it. Right? So I'm abusing the call stack to do my work here. Right? What's another risk of this? Let's go ahead and just go back down to 10. What if I had forgotten, say, to even do this recursive call? Right? What's going to happen now? 10, 10, 10, 10, and then what? Nothing. Why? Well, it printed 10, and then it did nothing, right? What if, I'll restore that. What if I forgot this thing right here, and I just had the print statement? What's going to happen now? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then keep going. Right? This is an infinite loop. Right? Eventually, as we said, when it hits about 320,000 some, it's going to die. But until then, it's just going without end. This is like a while loop again. It's a loop, but without an end. Right? There we go, finally. 327,056 function calls, give or take some change there. Right? So, with recursion, we need to use the same ideas from loops. We have a starting point. You want to start at 10. Right, let me go ahead and restore the code. 10. You have a starting point. You have a continuation condition. Right? As long as I is greater than or equal to 0, in fact, I'll go ahead and change that here. Right? Because if I started out at negative 10, I would have the same problem. But as long as I is greater than or equal to 0, then, is strictly greater than 0. There we go. If it's strictly greater than 0, then I will print it out and then call countdown on -1. So I have a termination condition. When I hits 0, I print blast off and I make no further recursive calls. I return. I'll make that explicit there. So I have a continuation condition, termination condition. When do you stop the recursion? I make progress towards my termination condition. Remember, with loops, you have an initialization, a continuation, and then an increment towards your termination condition. If I just went I every single time, right, that's going to be 10, 10, 10, 10, 10, 10, 10, 10, and never stop. I need to make progress towards that termination condition. Right? So yes, you can live in a world without loops, for loops, while loops, and do while loops. Do you want to live in such a world? No, me neither. But some people love functional programming languages, are a class of programming languages that you don't even have variables. You don't have loops. You have functions and parameters, and that's it. Right? You have some conditionals because you need to make a determination on when you're stopping. But otherwise, you just have these big giant function calls, function calling, function calling, function calling, function. Right? Those are pure functional programming languages like Scheme or Haskell, things like that. Now, not a lot of them aren't even pure. A lot of them say, okay, not everybody likes programming like this, so we'll introduce some features to make it more comfortable for people who don't like programming like this. But the thought process for pure functional programming languages is not, in my opinion, computer science-y thought process. It is pure mathematical thought process. Because as the name suggests, functions. You compose functions, you call functions, functions as inputs to other functions, reification, a whole bunch of other, category theory and all that kind of stuff coming from mathematics. If you love thinking in that, with that process, my undergraduate degree was in mathematics, but even I don't want to program in a goddamn functional programming language. No way, on a daily basis at least. But some people absolutely love it. you're not going to get that love from me. Instead, I'm going to show you the bad parts of recursion, and I'm going to show you how to deal with them. All right? And I'll show you that next time. Okay? Any questions? Yeah, go ahead.
Won't that code you have right now just print blast off every time?
Your last
Because of the gradient?
Oh, you're right. I need to switch this around. Thank you. Let's test it, make sure. There we go. We're back to normal. Thank you. All right. I'll see you on Wednesday.